Hi students, welcome back. We are here again in my kitchen with this sand, which my wife just absolutely loves. And we're going to talk again about weathering, erosion, and deposition. First thing I'm going to do, because these are cold, is put these ice cubes down right here at the top of this sand pile. And we're going to check on those at the end and talk a little bit about what happens with them. But first, I want to mainly focus on a question I might have left you with after my last video, which is, Ms. Reaver, you said you couldn't build us a real Grand Canyon because it'd take a few million years. My yard's also not big enough. But then you washed all that sand down to the bottom, and you're right, I went out on the deck and sprayed it off and all the sand is gone. So why did it take that long for the Grand Canyon to form? Wouldn't it just wash right through? Well, let's talk about that today. Let's see if we can change some factors in what we were doing here with our river to hold on to some of that sand and keep it up here at the top. I have a few hot box cups of science filled with water and ready to go. First, we're going to test and see how much sand comes down to the bottom if we don't do anything. We do it exactly the same way we did before. Now, you could make a funnel system and measure out the sand. We're just going to watch it and see how it changes. See what effects happen as I add in some barriers to this sand. First test, though, we're just going to pour some water on there and see what happens. All right, just like you remember it, right? All of this riverbank has changed and this sand has been washed away, eroded down to the bottom of my pan, bottom end of my pan, and deposited there after the water stopped moving. What can we change to make this better? Well, instead of having these tiny little particles, we're going to use a little gravel. Give me 1 second to clean this up and we'll build ourselves a little barrier. All right. We're back and I've got a barrier built up here that hopefully is going to hold some of my sand in. Let's see what changes as I pour my water onto this sand. Some of my gravel did start washing away. You can notice it's spilled down here, but look what else has happened up here at the top of my gravel. And actually, I don't think you can see it as well as I can, but some of this sand is snuck in between these rocks and grabbed together inside of them, so this area is not moving at all. We did still wash away kind of the banks here, but only a little bit of sand has escaped. What would be different if we poured even more gravel here? And what if we layered some inside of this sand that's up here? Could we keep even more sand right where it is? Let's give that one a try. Give me another second to get this cleaned up. All right, hot box of science going in on our sand and gravel mixture. All right, I hit it with a good splash there at the end, so we were able to break through that wall. But look how much less sand there is down here at the bottom. A lot of my sand has stayed up here at the top, and a lot of these rocks have held together, except right there where I really splashed that water against the side. A lot more sand is being held up here. It takes water a really long time to break down rock until it is this consistency that can be swept away, or even this consistency that can be swept away. And there's some other factors too, and this is where humans can come into play as well. Plants hold on to soil really, really well and keep it from getting eroded away, even if it's broken down into really fine particles. And you can see this if you've ever repotted a plant. I have a bunch hanging up over here. If you've ever repotted a plant that's been in its pot for a little while, it's grabbed onto all of that dirt and held onto it and said, nope, this is mine. It's connected to the roots with tiny little hairs. Humans, as we come in and cut down plants or cut down trees, we can change our surroundings because we loosen up some of that stick from the plants, from the roots of those trees, and then our soil, now suddenly these fine particles are loose and they're able to sneak away, and we can change our landscape a lot by changing what plants are planted in places. Now, I said I was going to talk to you about this ice. I don't know that my ice has worked super well. My sand is super wet, and this ice is probably not as heavy as I could make it. This was kind of a little sneak peek of some other weathering that we're going to be talking about starting next week. There's one more too, because we can also weather and erode with wind, with air. But you may remember all the way back to our first unit in social studies that the reason that Indiana is flat is because of glaciers from our last ice age that have come down and smushed all of the earth flat and deposited off some really great soil for farming in. Think about even bigger rocks than these being smashed by those enormous glaciers and then swept away and deposited all over Indiana, smoothed it right down. That is another way that our landscapes can change, and you'll learn some more about that next week. Hope you learned a little bit more about how the Grand Canyon formed and why it took so long to form the way it did. Take a good look, careful look at those layers of rock as you're continuing to explore the Grand Canyon, weathering, and erosion. Thanks for joining me.